Alright, this next one, please do not make the mistake of trying to distribute sine x into each of these set of parentheses. We need to expand these with our sum and difference formulas. This would read, so for sine of a sum, it's sine of the first, cosine of the second, plus cosine of the first, sine of the second, minus here, and then we expand, it is sine of the first, cosine of the second. This would be minus, but we are subtracting, so plus, and we want cosine of the first, sine of the second, and that equals half. Alright, that's a lot to write, but a lot of this is going to simplify down real quick. This term is a like term to this one, and they add to 0. So that's nice. Half of that mess is gone. Sine of pi over 6 shows up twice right here. Sine of pi over 6, let's just pull that value from the circle. The sine of pi over 6 is a half. So that makes this term a half cosine x. That makes this term half cosine x. So I have half and half, and I have just 1 cosine x equal to 1/2. So to solve this equation, where does cosine equal 1/2? Cosine equals 1/2 at two locations on the circle. That works at pi over 3, 5 pi over 3. Not too bad. Looked scary when we started, but in 2 steps it's just right down to just a single little cosine x. Alright, how about an equation that involves a double angle? How can we deal with this? Well, sine 2x, we've got a double angle formula for that. Sine 2x is 2 sine x cosine x. So we're here. Now, sometimes I don't like when I have multiple trig functions, like 2 different trig functions, but I don't mind in an instance where I can factor and solve by factoring. And there's a common factor of sine x here. So we take a sine x out, leaves us with 2 cosine x minus 1. And a factored form now, so we have 2 trig functions, yes, but each one belongs in its own factor, so we're all good here. We've got sine x equals 0. And we have this one equal to 0, which would be the same as cosine x equals half. Add the 1, divide by 2. So I want to know, where does sine equal 0? That happens at 0 and pi. Also at 2 pi, but we're not including 2 pi. And where does cosine equal 1/2? Cosine equals 1/2. We just saw that on the last slide at pi over 3, 5 pi over 3. Alright, we need to try a double angle problem that involves cosine. Now, if you recall, cosine is a challenging one because there are 3 options for cosine. Remember that I'd prefer it if I only had one trig function. Okay, well, since there's another trig function here, not part of the double angle piece, that is cosine, I'm going to use the trig function, or I'm going to use the choice for cosine 2x that only involves cosine. So, what is that? Cosine 2x, I believe, if I remember right, cosine 2x is equal to 2 cosine squared x minus 1. So there's my equation now. It's a quadratic equation, so I like to order the terms correctly. And then we'll try and factor this. To get 2 cosine squared, we want 2 cosine x times cosine x. To multiply the -1, we want -1 and +1, placed in such a way that my sum for the middle is negative cosine, and that would work if I place them this way. So we want to find where does cosine x equal negative half, and where does cosine x equal 1. So cosine is equal to negative half at, I'm going to say it's 2 pi over 3 and 4 pi over 3. Cosine is equal to 1, I'm going to say at 0. And we're finished. Alright, how about an equation with a tangent double angle? What might I do with that? Tangent of 2x, well there's only one option. Tangent of 2x is 2 tangent x over 1 minus tangent squared x. Okay. Minus 2 cosine x equals 0. Okay, so what to do with this? I'm just kind of guessing, so we're going to see where this goes. If I just put this over 1 and attempt to make a common denominator, the 1 would multiply there, giving me 2 tan x, minus, and then this denominator piece multiplies here, so 2 cosine x times 1 minus tan squared x. That's all over 1 minus tan squared x. It's equal to 0. The nice thing about this is now the denominator can just be ignored, because I could multiply this to both sides. If I multiply this to both sides, 1 minus tan squared x times 0 is still 0. So essentially I can just cross that out, I guess. Here we go. So we got 2 tan x minus, I'm going to go ahead and distribute 2 cosine x plus 2 cosine x tan squared x, it equals 0. This term is the one that concerns me. Let's see what we can do over here. So I've got 2 tan x minus 2 cosine x plus 2 cosine x. Tangent squared is, well, it's sine squared over cosine squared, like that. So let's see, this cosine, take away one of those cosines. Okay, so now we've got 2 tan x minus 2 cosine x plus 2 sine squared x over cosine x equals 0. Okay, I think we're going to need to go up here, keep solving. That first term, 2 tangent, is the same as 2 sine x over cosine x. The middle term, 2 cosine x, is the same as 2 cosine squared x over cosine x, plus the last term is 2 sine squared x over cosine x equals 0. So I'm gonna multiply everything by cosine. I multiply both sides of the equation by cosine. Those all disappear. If I divide both sides of the equation by 2, those all disappear. So now we've got sine x minus cosine squared plus sine squared equals 0. Cosine squared x. Cosine squared is the same as 1 minus sine squared. So now we have sine x distribute minus 1 plus sine squared equals 0. So I have 2 sine squared x plus sine x minus 1 equals 0. Factors 2 sine x times sine x there. I would go with plus 1 minus 1. So we want where sine x equals a half and where sine x equals negative 1. Sine equals 1/2. Let's make sure we don't mess this up at the very end. We've come so far. Sine equals 1/2, positive 1/2 at pi over 6 and 5 pi over 6. And sine equals negative 1 at 3 pi over 2.